Alrighty, guys, so we're going to continue on in our unit on parallel and perpendicular lines. And since yesterday we talked about the interior and exterior angles of a triangle, and I told you about how that's related to um, parallel lines. So what we're going to do is we're actually going to jump to polygons for a little bit and talk about angles in a polygon. And then tomorrow we'll come back into talking about lines, talk about graphing lines and kind of like a review of Algebra 1. But today is all about polygons. So first start out with some general facts about polygons, then we'll get into the angles, the meat of today's lesson. So in case you didn't know, a polygon is a closed plane figure with at least three sides that are segments. Okay? Segments being straight sides. Okay? The sides intersect at their endpoints and no adjacent sides are collinears. In other words, you're not crossing into the figure. So there's a polygon. Just straight sides. Nobody's coming into the interior space. Okay? If you want to name a polygon, you can pick any vertex and go either clockwise or counterclockwise. Okay? And about a convex and concave, you may have remembered this from middle school. That might be where you heard it before, but maybe not. Convex polygon, I kind of define it as all the sides point out. Okay, nobody comes into each other. So what I mean by that is, like that would be a convex polygon. Everything points out. Whereas concave, the sides might cave into each other. So you might start out making what looks like a four-sided shape, and then you might just cave in. So this would be a concave because it caves in on itself, okay? And then if you should know these names, hopefully you know these names, but in case we didn't, I added a table of the number of the sides of the polygon, which is always known as n. And then these are the names. Most of them, well, not most, some of them have names. Obviously, three sides is a triangle, four is a quadrilateral. In part B, there's a whole unit on quadrilaterals. There's specific kinds of quadrilaterals, which we'll focus on, but 5 is a pentagon, 6 is a hexagon, 7 is a heptagon, or instead of hepta, you could also see septagon. You could see that. Of course, 8 is an octagon. We know it's a stop sign. 9 is a nonagon. 10 is a decagon. 12 is a dodecagon. There actually is a name for 11, but we don't hardly ever use 11, so we just don't name it. And then usually anything above 12, we just call it the n-gon, so like 13-gon or 25-gon. But they might have names, but they're like so weird and far out there that nobody in real life uses them, so we just call it n-gon. Okay, and then we got to define what equilateral, equiangular, and regular are, because I'm going to use that word regular a lot, and you got to know what it means. So an equilateral polygon is when all the sides are congruent. So if you wanted to draw, I don't want to draw one, but think of an equilateral triangle that you learned in middle school. You know, in the equilateral triangle, all three sides are the same length, and so that's where equilateral comes from. Lateral being like a Latin word for side or something like that. Equiangular, which is a strange word, but it has the angle in it, so that means all the angles are congruent. And then we have what's called a regular polygon. A regular polygon has to be both equilateral and equiangular. So all the sides have to be the same, and all the angles have to be the same. And so an example of a regular polygon would actually be that equilateral triangle I mentioned earlier. You probably remember that all three angles in an equilateral, they're each 60 degrees, and then all the sides are the same, and so that fits the definition of regular. The regular quadrilateral, if you sit and think about it for a minute, would be the square. Every angle is 90 degrees, so that's the equiangular, and then every side's the same, so that's the equilateral portion. Okay, it's very important we know this definition of regular because it's going to come up in this lesson a lot. All right, now into interior angles of a polygon. So there's two things we need to talk about first. The first thing is about the sum. So if you added up all the angles in a polygon, doesn't matter if it's regular or not, just whatever kind of polygon, you're going to use this formula, n minus 2 times 180. N being the number of sides. Okay, so, and you'll see in a minute, I'll ask you, find the sum of the interior angles of a fill in the blank with whatever polygon you want. You simply have to know the number of sides, and 2 seconds in the calculator, you got it. The other thing is the measure of one interior angle of a regular, and I put this in bold. This formula that I'm getting ready to give you only works if your polygon is regular. If it doesn't work, you can't do it. So we start out with finding the sum of all the angles, and then when we have the sum, we divide it by the number of sides. And again, you can use your calculator here to figure this out. So the sum is sorry, my speech impediment's acting up. The measure of one interior angle of a regular polygon is this formula. All right. So let's flip over. So all we really have to do is pay attention to what we're being asked, and everything should be okay. So find the sum of the measures of the interior angles of a 15-gon. Okay. So I'm looking for some keywords. It says sum. So that means I'm going to use that first formula. The n minus 2 times 180. My side is 15, and so simply 15 minus 2 times 180. And you'll type that in a calculator, and you should get 2,340 degrees. Let me verify that. So 13. This would be 13 times 180. Yeah, 2,340. So any kind of 15-gon, when you add up all the angles, you're going to get 2,340 degrees. That's what that means. Find the sum of the measures of the interior angles of a nonagon. So this time we have to remember what nonagon means. And from earlier, we know that means the number of sides is 9. And now that we know the number of sides, we can go substitute it in. This would be 7 times 180, and when you figure that out, 1,260 degrees. And I need to see degrees because we're talking about the sum of angles here. So you got to tell me what kind of 1,260 we're talking about. Okay. Find the measure of one interior angle. So one interior of a regular heptagon. So this is where I can use the formula from earlier. So it starts out the same as earlier. So what's a heptagon again? That n is 7. So 7 minus 2 times 180 all over, whoops, that should have been a 7. And we'll just evaluate that. And so there's a couple ways you could type this in. Let me put it where you can see it. Whoops. Oh, it died. That's funny. Okay. So to type this in, you could use the alpha y equals key and type it all in as one fraction. So 7 minus 2, 180, come down and do 7. The only thing about that is it's going to give it to you as a fraction. So then you'll have to go to the math menu. You want the decimal answer. And then because it's a heptagon, the angles are a little bit odd. They're not exact. So we're going to round this to 128.57 degrees. I chose to round to the hundredth, but you could really round to whatever. I didn't really tell you what to do. The other way is you actually type the top part in first. So do the total sum first, 900, and then divide by the number of sides. So either way. All right. Find the measure of one interior angle of a regular 16gon. The same formula. 16 minus 2 times 180 all over 16. And we'll just go type that in. 16 minus 2 times 180 is 2520. Divide by 16. And we get 157.5 degrees. Okay? Now, these problems are the reverse of what we just did. So the measure of one interior angle of a regular polygon is 135 degrees. Find the number of sides. So in this instance, we've done this work and gotten to this. I'm trying to figure out what we plugged in for n. So what I'm going to do is I'm going to take this measure and set it equal to this formula, but with n's in it. So 135 equals n minus 2 times 180 all over n. Now to solve this, we could do cross multiplication. There's an invisible 1 under here, so I'm in practical sense, I'm just going to ignore it. And so I would cross multiply 135 with the n and get 135 n equals this top again. All right. Now, it looks weird, but this is actually distribution, so I'm going to distribute the 180 to the inside here. So 135n equals 180n minus 360. If this is bothering you that I wrote the 180 at the end, you could put it in front here. It doesn't matter where it goes. I was just taught, and I was taught to put the 180 at the end, so that's what I do. But you could put it here in the front if you wanted to. Okay. Now we need to move some terms. So I kind of told you I'm not in the habit of telling you, move the smaller variable first. But in this instance, I'm thinking ahead, okay? If I move the small one, that's going to come over here. So now I'll have 0 equals some variable, subtract 360. Then I'll have to bump the 360 over. Okay? And you could totally do that. That's totally fine. I'm actually going to move the 180 because it's one less thing I have to write. So I'm going to subtract the 180 in. And so that's going to get me negative 45n equals negative 360. Then we'll have to divide negative 45. Make sure you leave the negative there, because you're trying to tell me the number of sides. So negative 360 divide negative 45. That's going to get you 8. Number of sides is 8, so that is a octagon. Okay? So again, sorry I'm pausing, I'm thinking about something. Okay, never mind. Go ahead and do it. So same setup, 162 equals n minus 2 times 180 over n. Multiply 162 with n. 162n equals n minus 2 times 180. Do your distribution. 162n equals 180n minus 360. So subtract 180n. That will get me negative 18n equals negative 360. Divide negative 18. Divide negative 18. And so n is 20. So this would be a 20gon. You don't have to write out the name of the polygon. I just did that, so for funsies. Okay, so I'm going to say something here, and then I'm going to come back to this thought. These 4 problems right here, there actually is an alternative way to do them instead of using this formula. And it involves the exterior angle. So after I talk about the exteriors, I'm going to come back and revisit these, and I'll add them off to the side. And I'm going to let you choose however you want to solve that kind of problem. Okay, you can either do this way or the second way that I'll show you here in a minute. Anyway, let's come down here to exterior angles. So now we're going to look at angles that are outside the polygon. The sum of the sum of the measures of the exterior angles of any polygon is 360 degrees. Always. It does not matter what the polygon is, whether it's a triangle to a 250gon. You add up every single exterior angle on that polygon, you will get 360. Okay? Now, if your polygon is regular, you can find the measure of one exterior angle. So the measure of one exterior angle of a regular polygon is you take the 360, divide it by the number of sides, which is what these two down here are going to show us. Actually, no, sorry. Yeah, it is. I can't read. Find the measure of each exterior angle of a regular pentagon. So remember, what's a pentagon? That means we have 5 sides. So 360 divided by 5, that will get you 72 degrees. And that's it. Find the measure of each exterior angle of a regular 24gon. So 360 divide 24, and that will get you 15 degrees. Easy peasy. Okay? If the exterior angle of a regular polygon is 30 degrees, find the number of sides. So it's like we've already done 360 divide n, and we found the answer to be 30. So you're trying to tell me what the n was. And so we can cross this. There's an invisible 1 under here. And so we can kind of do cross multiply. 30 times n, that would be 30n equals 360. Now we have to divide 30. And so when we do that, we should get 12. So this would be a dodecagon. Right, same thing. The exterior angle of a regular polygon is 225. So we've done 360 divided the number of sides, and we ended up at 22.5. Cross multiply, 22.5 n equals 360. Divide 22.5. That's going to give us 16. And so this is a 16gon. Okay? So that's all that. Now I'm going to come back and, remember I said I'm going to come back and revisit some of these up here. It actually uses this formula right here, what I'm talking about. So if you can envision, let me draw just a triangle, I guess that'll work. I'll do a regular triangle. It really doesn't matter. Anyway. Okay, so in this triangle, we would say that this angle and this one, that is a linear pair. And so when you add them up, they're supposed to be 180. So on a problem up here, where I want the interior, you can actually find the exterior first because honestly it's less work. It's 360 divided the number of sides. And then you do 180 subtract whatever this is, and that will get you the interior. So let me show you what I'm talking about. So on this problem up here, let's find the exterior first. So 360 divide the number of sides. And if you round that, that will be 51.43 degrees. Now, because this angle and whatever the interior is, they make a linear pair. And so we will do 180 subtract 51.43, and that will get us what we found up here. So this is the way I was taught, and it's stuck in my mind to do that. I've recently figured out you could do this. Nothing wrong with this one. It's a little more work, I think. Most kids remember this one, I think, sometimes. Either way you want to do it is valid. I don't care. As long as you can find the measure of an interior angle of a regular polygon. I'll leave this one for you to check if you want to. I'm not going to do it here. On this problem, you're trying to find the number of sides. And so what you could do first is you need to figure out the exterior angle, because it would be like this. It'd be similar to this problem back here. If you know the exterior, you can find the number of sides. You simply divide 360 by whatever the interior angle is, or the exterior is, sorry. So let's find the exterior angle first. So we know the interior is 135. So we'll come over here and do 180 minus 135. That gives us 45. Now we know what the exterior is. We can take the sum of the exterior, divide it by the singular one, and that will get us the number of sides. So first find the exterior, and then divide that 360 by that exterior angle, and that will get you the number of sides. Now, I would probably want you to use this one more than this one, unless you just want to write out this equation and do all of it. I really don't care. Either way is fine. I don't care. You get to pick. Okay, so that's all about polygons. This homework assignment for this lesson is actually going to be on paper, so it's the one paper assignment for Unit 3. So make sure you watch the video in its entirety, do your homework problems, and as always, if you have questions, let me know.